Hi, my name is Rich Nolan from Nolan Engineering in upstate New York. Today we're going to talk about drilled or notched or damaged floor joists. We're going to start off by talking about what's allowed for drilling and notching, and then at the end of this video we'll show you a product that we have if your joist is notched or drilled beyond what's allowed. So we'll start off by showing you what's allowed in most building codes. This here is a 2x8 piece of lumber. What's allowed for drilling and notching depends on the depth of the lumber. So we're not going to talk about a 2x4 piece of lumber because 2x4s aren't allowed to be used as floor joists. And we need to know the true depth. So a 2x6, for example, is not 6 inches deep, it's 5.5 inches deep. A 2x8 is 7.25 inches deep. 2x10 is 9.25 inches deep, and a 2x12 is 11.25 inches deep. So all the notching that you're allowed to do and drilling that you're allowed to do is based on the true depth of the floor joist. As far as end notching goes, you are allowed to notch up to 1/4 of the depth of the joist, and that's sometimes necessary to get it over top of a beam or a wall. A notch at the top of the joist can be 1/6 of the depth and no more than 1/3 in length of the depth of the joist. In the center third of the joist, you're not allowed to have any notches. That's because the stress is the highest in the center of the joist. So you're not allowed to have any notches. A notch on the bottom of the joist can also be the same as the top, 1/6 the depth, and the length can be greater than, cannot be greater than 1/3 of the depth of the joist. If you are notching the bottom of the joist, it's best to taper your notches so you don't split the wood. You can pre-drill holes in the corner to make the corners round and cut a taper. That's a lot less stress on the wood. Holes are allowed pretty much anywhere except for within 2 inches of the end of the joist. So you can have holes in the center third of the joist, but not notches. Holes must be located 2 inches from the top, no closer than 2 inches from the top, and also no closer than 2 inches from the bottom. The spacing between holes cannot be less than 2 inches. The diameter of the hole cannot be larger than 1/3 of the depth of the joist. So that is what's permitted by code, and that is what's allowed by code. Now, if you do have notching or drilling greater than that, an engineer can always override the code, but you'd have to let them know because they'll have to do some calculations to see if it's acceptable. Just going to show you a couple examples of pictures of notching. You've probably seen that yourself. Obviously, notching or drilling holes is needed or done for plumbing or ductwork or wiring or some other obstruction. This hole doesn't meet code for 2 reasons. First of all, it's less than 2 inches from the bottom of the joist, and second of all, the diameter of the hole appears to be greater than 1/3 of the depth of the joist. This next photograph here, these are notched up fairly bad. Again, the notches are greater than what's allowed by code, greater than 1/6 of the depth of the joist, and some of them may be located within 1/3 of the joist, and this particular one here is longer than what's allowed. And just another picture of a typical notch. And here's one notch that was made for plumbing that someone attempted to repair at the bottom. And I'm sure you've probably yourself seen some joists that have been notched out pretty bad. Here's a hole through TJI joist that appears to be too large as well. Now I want to explain to you the behavior of a floor joist or a beam or a floor joist when it's loaded up with a load. I have a floor joist here that has a notch, and it's also been cut straight through and it's hinged on top. So as you apply a load to any joist, this is what happens. You develop tension in the bottom of the wood and pressure at the top of the wood. So as you can see, if you cut out a notch, there's no material left there to absorb that tension, and it'll eventually split open and fail. Mostly, if you see this in the field, there's really only one way of repairing this situation, and that's what's called a sister. They'll come alongside and they'll sister a floor joist alongside. The problem with that is, there's a few problems. First of all, it's usually there's plumbing and wiring going through the joist, and removing that plumbing and wiring and rerouting it is very expensive and time consuming and sometimes difficult to do. Another problem is it's hard to get a sister in place because it's typically very long. You have to fit it over the foundation wall, you have to fit it over the beam, there's stuff in your way, so it's a very difficult thing to do. We've come up with a product that alleviates that, allows you to leave your pipes and your plumbing in, but also restore the strength of your joist, and I'm going to demonstrate that for you now. What we've come up with, we call the joist repair kit. It's essentially a strap that's been specifically designed to attach to the bottom of the joist and absorb that tension force. It's been designed for the longest span joist that you can have per code under a full design load. The kit comes with the strap with the pre-drilled holes, a drill bit for you to drill pilot holes, all the screws you need, and the nut driver to install the screw. So I'm going to go ahead and install the strap at the bottom of the joist with just a couple of screws because I won't be loading this up fully at this time, just to show you the effectiveness of the strap. Now this strap takes 32 screws, 16 on each side, and that's necessary to restore the full strength of the joist. But for this demonstration, I'm only going to be putting in a couple in on each side. So you want to pre-drill the holes. I have the holes already pre-drilled. And you just want to snug it up. You do not want to split this wood. These are 1/4 inch structural screws. They're very strong. You notice I'm just snugging it up at the end, not overdoing it. Now this joist is very strong, and that's only with 3 screws. So when you have all the screws in, this would be just as strong as the original joist, even for a 2x12 spanning 17.5 feet. If you stuck around for the rest of this video, I'm just going to finish up with some of the calculations to show how this works. So for a typical floor system, we designed for a dead load of 10 pounds per square foot. And if it's a first floor, a live load of 40 pounds per square foot. Typical joists are spaced at 16 inches on center. So we have to just count for that. So 10 plus 40 is 50 pounds per square foot. But we have to multiply that by the joist spacing of 1.33 feet, which is 16 inches. So each floor joist would see 66.7 pounds per linear foot. So if I have a floor joist, let's say this is a 2x12. A 2x12 maximum span in most building codes is 17.5 feet. Put our floor loading on. Floor loading is our 66.7 pounds per linear foot. We have our reaction loads at both ends, which is basically 66.7 times 17.5 feet. So each end sees 584 pounds. On the wood's designed for 4 things. Usually crushing. You don't want to crush the wood, deflection, shear stress, and bending stress. We're just going to look at the bending stress right now. We want to find out the maximum tensile force, as we showed with that demonstration, is at the center of the joist. So we need to find out how much tensile force we need to hold that joist together if it's notched. So I'm just going to take half of the joist, put my loading back on, We know that the end reaction is 584 pounds. We'll take the moment about this point here. This is our cut joist. We're cutting the joist right in half. So there's some kind of a tension here that's needed so this joist doesn't fail. So what we're going to do is we're going to take the moment about this point here. So we have 584 pounds. Let's call this positive direction. So that wants to spin it this way. So we have 584 pounds times this length, which is 17.5 over 2, which is 8.75 feet. Then we have the moment caused by the loading on half of that, which also happens to be 584 pounds. And that would be multiplied by this distance here. So we have 584 pounds times that distance is 4.3758 feet, I believe. I think that's a little off, but it's close enough for now. And then we have the tension that has to equal. And this is a 2x12 joist, so that tension force is acting over a distance of 11.25 inches, which is 0.9375 feet. So if we solve for T, we get T equals 2,725 pounds. So if we have a notch joist or a joist that's cut all the way through, in order for that joist not to fail, we need to restore a tension of 2,725 pounds. And that's exactly what that strap's designed to do. It has a thickness to do that, and that's why it requires so many screws, because that's quite a bit of load. Now if you have a shorter joist or one that's not loaded as much, that strap won't see nearly as much. Or if that notch, instead of being in the middle, were to be located somewhere at the end, again, it would not see that much as the bending stress goes to 0 as you get closer to the ends, and it's maximum in the middle. So thank you for watching this video. If you would like to purchase these straps, they are available on Amazon.com, or you can call us at the office 518-280-3190. And I thank you again for watching.